This question show that if n is a positive integer, then we need to show that the 3 to the power of n plus 1, 3 to the power of n plus 3 to the power of n minus 1 is divisible by 13. Okay, so for here, remember that we want to show that being divisible by 13, remember I told you in class, it means that it contains, example, to be divisible by 13, this means that your guy, right, must have 13 as a factor. It must be a multiple of 13. Okay, so it basically says that if it need to be written, this number must be so equals to 13 times k, where k has to be an integer, of course, right? K has to be even not even okay, so it's an integer. Okay, so how do we go about doing that? So that means if we want our number to be written in this form, so think about it, it's like writing it as a form of factor. Okay, so this is the same as taking it and factorizing. We're basically factorizing. Okay, we need to factorize this guy. So to factorize, as we know, we need to identify the common factors of all the terms. And looking at these, right, you see all terms here, 3 power n plus 1, 3 power n, 3 power n minus. If you can actually see, right, the highest common factor, right, is 3 to the power of n minus 1. Alright, I mean, if you cannot really see that, let me just give you a simple numerical example. If you 3 power 1, 3 power 4, and 3 power 3, then you can see that the highest common factor here, right, for all these three guys, right, because this can be written as 3 power 3 times 3 power 2 plus 3 power 3 times 3 power 1, and 3 power 3 is like 3 power 3 times 1 or 3 power 0. You can see that these guys are basically the common factors. They are basically the common factors. Basically the highest common factor. Okay, then this is the same as 3 to the power of 3 times 3 square plus 3 power 1 plus 1. Okay, so in this context, since this numerical example is okay for you, using this, right, I can write this as 3 n plus 1 basically is the same as like n minus 1 times 3 power 2. 3 power n is the same as 3 to the power of n minus 1 times 3 power 1. 3 to the power n minus 1 is basically the same as 3 to the power of n minus 1 times 3 power 0 lah, huh? So if you look at these three guys, right, they actually are the common factors. And I take out 3 to the power of n minus 1. Now what is left is basically, you can see those remaining, this guy plus this guy plus this guy. So they're all going to be here. 3 power 2 plus 3 power 1 plus 3 power 0. That gives us 3 to the power of n minus 1 times 9 plus 3 plus 1, that's just 13. And you can see, whoa, you see, as we have wanted to show, that this is indeed the form of 13 times k. 13 times k. Alright, it would not have been possible unless we knew that we were going to factorize. Our numbers. Okay, so you can see that the power of factorizing helps it to get our answer in this manner. Now, since n is a positive integer, and 3 to the power n plus 1 plus 3 power n plus 3 power n minus 1 can be represented in the form of 13k. Okay, where k is an integer, you can see that 3 to the power n plus 1 plus 3 power n plus 3 power minus 1 is indeed divisible by 13. Okay, so this question, basically a question on divisibility, checking whether a sum of indices are divisible by a certain number. Really, the method to go about doing this is by first you need to identify the highest common factor between the terms and you factorize. So not only must you be good with the law of indices, you must also be good with factorizing the individual terms out. Alright? Okay, so I hope this is useful for you.